Today we are going to embark on a journey that challenges the very limits of human perception and takes us deep into the heart of geometry. We are here to perform an anatomy of a tesseract. To understand this complex four-dimensional shape, we cannot simply jump into the void. We must follow the strict logical progression of mathematics that defines our reality. If you think about the world around you, you see objects with length, width, and height. But to understand the tesseract, we have to look at the rules that govern these dimensions and then push those rules into a space that we cannot physically picture in our minds. Let's start with the most basic building block. Imagine a single connects piece representing the first dimension, a simple straight line. In this 1D world, there are only two vertices, the endpoints. At each vertex, there is only one line. Now, to move to the second dimension, we follow a specific rule. We add 3 more of these lines and connect them so that all adjacent sides are perpendicular and all opposite sides are parallel. This gives us a square. If you look at any corner or vertex of this square, you will notice that exactly 2 lines meet there. This is a crucial pattern. In 1 dimension, 1 line meets at a vertex. In 2 dimensions, 2 lines meet at a vertex. To reach the third dimension, we follow that same logical progression. We take our 2D square and add 4 more squares, connecting them so that once again, all adjacent sides are perpendicular and all opposite sides are parallel. This creates the cube. Now, look at any vertex of that cube. You will see that 3 lines meet at that single point. This is the world we inhabit. We have length, width, and height, and our geometry is defined by these 3 lines meeting at 90-degree angles. But the logic of mathematics tells us that this pattern does not have to stop at 3. If we can have 1, 2, and 3 lines meeting at a vertex, there is no reason, mathematically speaking, why we cannot have 4. This brings us to the tesseract, the 4-dimensional basic shape, also known as a hypercube. To construct a tesseract in your mind, you must attempt to follow the same rule we used for the cube. You take a 3D cube and you add more cubes to it. Just as a 3D cube is comprised of an infinite series of 2D planes stacked together, a 4D tesseract is logically made out of an infinite amount of 3D objects. Specifically, just as a square has 4 lines and a cube has 6 faces made of squares, a tesseract is composed of 8 cubes. These are not just stacked like building blocks in our 3D space, because that would just result in a larger 3D object. Instead, these cubes are connected in a way that requires a 4th spatial direction, one that is perpendicular to length, width, and height simultaneously. In this 4-dimensional anatomy, the most striking feature is the vertex. In a tesseract, there are 4 lines connecting to each and every vertex. This is where our 3D brains begin to fail us. In our world, you can have 3 lines meet at a corner and all be at 90-degree angles to each other, like the corner of a room where the floor and 2 walls meet. But try to imagine a 4th line coming into that same corner that is also at a 90-degree angle to the other 3. You cannot physically picture this because we are 3-dimensional creatures. Any drawing you see of a tesseract, usually showing a cube within a cube with the corners connected, is merely a 2-dimensional depiction of this 4D concept. Because it is a projection, the lines in the drawing look slanted or crooked, but in the true 4D tesseract, every single one of those lines is perfectly straight and every angle is exactly 90 degrees. One way to help visualize the 8 cubes that make up a tesseract is to think about the cube within a cube model often used in diagrams. In this 2D representation, you see the inner cube, the outer cube, and then the 6 distorted cubes that connect the faces of the inner one to the outer one. In the 4th dimension, those 6 connecting shapes are not distorted at all. They are perfect cubes, identical to the inner and outer ones. They only look different to us because we are seeing a 3D shadow of a 4D object, just as a 3D sphere looks like a 2D circle when its shadow is cast on a flat wall. This leads us to the fascinating problem of perception. We live in a 3D world, but we actually perceive it in 2 dimensions. When you look at an object, your eyes see a flat image, and your brain uses the hues of light and shadows to interpret depth. If you saw a 4D tesseract passing through our 3D space, you wouldn't see the whole thing at once. You would see 3D slices of it. A 4-dimensional creature, however, would have a much more profound perspective. Because they see in 3 dimensions, they would be able to see through 3D objects. They could see the inside and outside of a cube simultaneously, just as we can see every part of a 2D square drawn on a piece of paper. To a 4D being, the 8 cubes of a tesseract would all be visible at once, perfectly interconnected by those 4 lines at every vertex. It is important to remember that this fourth dimension we are discussing is a spatial dimension, not time. There is a common misconception that time is the fourth dimension, but time is not spatial. While time exists in every dimension, the tesseract represents a direction in space that we simply cannot move in. If we could move in that fourth direction, we could step out of our 3D world and look back at it, seeing inside houses and even inside people, because we would be looking from a direction that doesn't exist in 3D space. The anatomy of a tesseract also points to a larger possibility, the existence of infinite spatial dimensions. If we can move from 3 lines at a vertex to 4, why not 5? Why not 71? The mathematical logic suggests that there is an infinite series of worlds stacked upon each other, each one invisible to the one below it. Some physicists even suggest that our entire 3D universe might be curved in a way that we cannot see, forming a massive 4-dimensional shape. Just as a 1D line could curve to form a circle, or a 2D square could curve to form a sphere, our 3D world might be a curved surface within a 4D universe. Ultimately, the tesseract serves as a bridge between the world we can see and the vast, invisible realities that mathematics tells us must exist. We can count the 8 cubes, we can calculate the 4 lines at every vertex, and we can follow the logical progression from a point to a hypercube. We may not be able to picture it with our eyes, but through the power of logic, we can understand its anatomy. We are 3-dimensional beings living in a world of 2D perceptions, looking up at a 4D ladder that goes on forever. The tesseract is just the first step into that next dimension.